Alright, so today we'll be talking about the algebraic equations and equalities from chapter 12. Okay, so remember the in the last class we talked about the algebraic equations, right? We know the variables, we know the coefficients, right? We know the operators, right? So here today we'll talk about how we can find unknown or variables in an algebraic equation. Okay, remember the equation means you have equal sign, right? Equal sign, and then you have two different algebraic expression in both sides of the equal sign, right? And theoretically that means the both of the expression is equal, but there are some unknowns, meaning like variables. You have to find, let's say you have to find some values of the variables, right? So again, we write the equation just to make sure that both of the sides are equal. Okay, only when both of the sides are equal. And again, a couple of steps. Sometimes we miss. We just want to make sure that we understand it. So let's say the following equation is not true because of this. Let's say you said 22 by 2, which is actually 11, but we are also adding 5 here, which is not true, because if you are putting an equal sign, you have to make sure that every single side are equal, right? Because in the right side is actually 16 and the left side is actually 11, right? So what happens is, if you have to write an equation and if you are adding or manipulating it, make sure you follow some steps. Meaning, let's say if you are adding 5 here, you always should be adding 5 in the left side as well, because you always have to keep the left and right side same, right? So if you add something in the right side, you must have to add something in the left side as well. That's why it's not right. Okay, and you can always solve equations like these. For an example, let's say you are given an equation, right? X plus 3 equals to 10. Now what might be the value for x, right? So you can sometime, if it is, since it is an easy equation, you can plug 7 and see that makes it 10, right? But sometimes it's not that easy just to look and see and find, right? So we'll show you some steps and techniques to learn those, okay? And always make sure, if you do some math, for an example here, what happens? You have x plus 3 equals to 10, but you subtracted 3 in the right side, but you did not subtract in the left side. That's what I'm saying. If you do any operation, you actually have to do the same operation to the both sides, right? Okay. All right. So here, same is here. We have an equation. Let's say we want to divide both sides by 2. But look at this one. We divided right side by 2, but not the left side, which is again false, right? You cannot do that. If you do any operation in one side, you have to do the same operation in both sides. For an example here, let's see, if you divide 2, look at this, we divided 2 both sides, right? Here you divided 20 by 2, here you divided 2x by 2, that's why 2 is gone. Then you end up having like x equals to 10, which is actually the solution for the equation, right? So similarly, we have several things we have shown here. You are subtracting 10, but you have to subtract from both sides, right? Which we actually did here. I'll actually show you some steps how to solve the equations, okay? This is a similar one where we actually added 2x both sides, okay? And subtracted 4 from both sides. Okay, so I'm skipping some of these because I just want to show you the steps, okay? Now, what do we mean by isolating the unknown? For an example, in the algebraic equations, what happens is, as you have seen that in the equation you have some numbers, right? You have some operators, you have equal signs, you also have equal sign, and you also have unknown, right? Now using one equation you actually can solve or find one unknown. So again, if you have 2 unknown and you have one equation, there is no way you can solve it. So that means using one equation you can find the value of one unknown. Now how you do that? The steps you follow there is called isolation steps. So that means you are actually isolating the unknown. What do I mean by the isolating the unknown? So whatever the equation you are given, okay, let's say the x is unknown. You actually have to follow some steps so that the x is isolated than every single other thing, okay. So at some point you will see that x is the only thing that will be remaining in either left side or the right side of the equation. So to do that, what we do is we actually transpose some operations. If something is added with x, we subtract it. You see what I'm saying? If something is multiplied with x, we divide it. If something is divided with x, we just multiply it. We just do the transposing operation to get rid of everything, okay? If something is powered with x, we do the square root of x, let's say. Let's say if it is x squared, what do? We do the square root, right, to get rid of a square. We'll show you some steps, okay? And remember, whatever you do, we always have to do it on the both sides. Again, since this is an equality, right, both sides we do the same operation. Okay, let's try some equations. So for an example, let's look at the first equation here. Now 2x plus x plus 5 equals to -4. Now what is unknown here? X, right? So that means you will be solving this equation to find the value of x, right? Now, so let's first add the x's. 2x plus, because these are like terms, right? Remember last class? These are the like terms, so we can add them. So make it 3x plus 5 equals to -4. Now, since you were trying to find the unknown, which is x, you actually have to isolate the x. How do I isolate the x? Now think about this expression here, 3x plus 5. If you have to isolate the x from here, what steps you need to do? You have to get rid of 5, right? Which is added. You see what I'm saying? Let's get rid of that 5. Now how you get rid of this 5? Look at this. 5 is actually added, right? So only way you can get rid of 5 is just by subtracting 5, because 5 is added. So what I did is in the next line we subtracted 5. But as I said before, you have to do the operation in both sides. So since I have to subtract 5 here, I'll be subtracting 5 here definitely, because I have to do the same operation both sides. I actually wanted to get rid of 5 from left side, but still I do the subtraction in the right side because I do the same operation both sides. Now once I did that, I have 3x equals to -9. I'm not done yet because I still don't have x isolated, right? So what I need to do to isolate the x, I need to get rid of that 3, right, which is multiplied with x. So how do I do it? I'm saying, remember, I have to transpose it, right? So reverse operation. Since the 3 is multiplied, I have to do a division by 3. So here I did that. I divided both sides, but remember, both sides, right? I'm actually trying to get rid of this 3, and that's why I divided by 3, but I have to do the operation to the both sides. So I actually did it here as well. And at the very end, as you can see here, x is actually isolated, right? On the right side, we now have -3. That means the value of x is -3. That's exactly what we are looking for. Remember, we are trying to find the solution for x, right? This is the solution of x. And now x equals to -3, but if you really want to double check whether you did it right, you can plug this -3 into the original equation. Remember, this was the original equation, right? I plugged it back. I just replaced the x by -3. And then I do my math, and I found that right side and left sides are equal, right? That means I did it right. I'm saying if your value of x is right, if you plug it back to your original equation, you will always find the left side and right sides are equal, right? Any question here? So pretty much we'll be doing the similar stuffs, okay? But remember, in the multiple choice question in the quiz section, sometimes we do the backward, because let's say we're given 4 answers, we plug it into the equation and we see which one is right. But I would strongly recommend try the steps. I'm saying, because you need to learn actually how do you solve the equation, okay? Let's try to solve a couple of equations. And a couple of ones are pretty easy because you even don't need to solve most of it. let's say if you just plug 7 here, you can see that's right? So x equals to 7, right answer is A, right? So you know, we also showed you the step. But if you really follow the steps, what you need to do is you subtract 3 from both sides, right? To isolate the x. Once you subtract 3, all you will have is x equals to 7. Because you subtracted 3 from right side as well, right? Okay, let's try another equation here. Now look at this one. What is the value of x? When you will be doing this in your homework section, try to write it down. I'm saying don't think everything. I'm saying write it down and show the steps and go over it, okay? Now let's try to solve it. Now what I did is again my goal is to isolate the x, right? So I started here, I added 10 and 3, that's my like terms. Once I have that, I have to get rid of this 13, right? I subtracted 13 from both sides. Now I have negative x equals to negative 2. So I still have to get rid of the negative sign, right? To get rid of negative sign, most of the time what you do is we multiply both sides by negative 1. You know what I'm saying? If I multiply both sides by negative 1, this x becomes positive x. And automatically the right side is also changed because you have to do the multiplication both sides, right? Now my x equals to 2. And that's my solution. In the later step 4, in the step 4, we actually have shown you verification. I'm saying you plug it back to the original equation to double check whether you did it right. That's an optional step, but if you want, you can always double check. Okay, let's try another one. So look at the interesting thing. Now we have unknown here. Which one is the unknown? Y, right? How do you solve y? So let's try a couple of maths. So for an example, we added and subtracted in the left side, which make it 15. Right side we have 11. So we actually have to get rid of this negative 11 first, right? Because we want to isolate y. To isolate negative 11, we added 11 both sides, right? In this step 2. Then we have 26 equals to negative y. And again, to get rid of negative sign, here we have to multiply both sides by negative 1, right? Then we get y equals to negative 26. We just multiply both sides by negative 1. And we wrote y in the left side. I'm saying that's not required, but a lot of times we want to see the unknown in the negative side. That's like a convention, you know, it's not required. So step 4, we actually verified the answer. Any question here? It's actually easy. So now we have 3 multiplied with x. To get rid of this 3, what do? We divide both sides by 3, right? So it's actually x becomes x equals to what? 9. Right answer is what? C. Here are the steps. Let's try another one. 4y equals to negative 64. You divide both sides by what? 4. Then y equals to what? Negative 16, right? Right answer is B. We also have shown you the steps here. I'm saying this is easy, so it's just one step. All right, this is interesting. So you have 7 divide A is divided by 7. Remember, the unknown is A here, right? What do? How do you solve it? You multiply, right? Because it's division. Multiply by what? 7, both sides, right? So A equals to 42 now. The right answer is D. Last one. It's easy. This is more interesting than probably we think. Now, how do you solve these? This is interesting because B is a denominator here, right? People have a lot of way of doing it. I think what you can do is, I'm saying, you know, again, don't think that there is only one way of solving it. There might be multiple ways and all the ways are right, okay? The only difference is if you select the best way, it might be lesser steps, okay, but it will be pretty same. So what I would do here, if you don't like, you can try another one, but what I would do is, because it's like 3 over b equals to -9, right? So what I'm going to do is, because I have my b in the denominator position, which is a bit of a trouble, okay? So I would multiply both sides by b. What happens here? If I multiply both sides by b, you might be thinking I'm getting rid of b, right? But you are getting rid of b in the left side, but you'll be getting a b in the right side. So you still have the same thing, right? So, but at least the b is in the numerator position right now, right? So b will be cancelled in the left side. So it will be like 3 equals to -9b. Now it's easy, right? What is the next step? You have to so you see the b is still multiplied by what? -9, right? So you can divide both sides by -9, because you still want to get rid of -9, right? So -9 get cancelled in the right side. In the left side it becomes -1/3, which is the right answer. So the right answer is actually A, right? Any question here? We actually did the same steps here. So, that's pretty much the steps, in case in case you want to remember what you did on the whiteboard. That's exactly the same steps we did here, okay? We did that we have in this slide. And step 4 is the verification, okay? And this is optional, so in case you want to check. How about this equation here? What is different in this equation? Now this equation is a little bit different than what we have done so far, because the unknown is what? X, right? But do you see you have unknown in both sides? That's something that we have seen for the first time, right, in these slides. Now, first of all, if you have this situation that your unknown is in both sides, you actually have to bring all the unknowns in any of the side, either left or right. So for an example, what you would do, you probably would try to get rid of 3x in the left side, from the right side, which will actually bring all the x in the left side. So let me show you the steps. So what I did is, I'm trying to get rid of -3x from both sides, from right side. So that's why I added 3x, because that's what I want to get rid of, right? But I have to add 3x in both sides. And that becomes, so I did my little math here. So I have, and I also did this. Once I have 1 here, because I want to get rid of everything in the left side except x, right? So I want to get rid of this 1. So that's why I subtracted 1 from both sides. So I don't have 1 right now in the left side, so I have just 10x. In the right side, I have just -10. Now it's very simple, because 10 is multiplied with x. I divided both sides by 10, so that I can get rid of 10 multiplied with x, right? Which gives me x equals to -1. Any confusion here? Oops. Now, how about here? How do you find the value of A? So one option is you can multiply, you can distribute A, meaning multiply A with 7, multiply 4 and 7, because you're distributing it, right? So then you get 7A plus 28 equals to -7, and rest is easy, because you just have to get rid of this 28, and you subtract the 28 from both sides, right? Once you subtract 28 from both sides, you just have 7A equals to -35. And then you divide both sides by 7. Since you have 7A here, right? You got rid of 7, A equals to -5. That's your answer. In the step 6, we actually verified the answer. Any question? You have question? Okay. Okay. Yeah, you have to practice, of course, yes. Yeah. Now, this one has power. Remember, if we have power, we actually take the root. So for an example, we have x cubed equals to 27. So to get rid of the power, we do the cubic root, right? Cubic root of x. So and cubic root of 27, which gives us x equals to 3, and that's it. Because cubic root means what? You have to find a number which is multiplied 3 times by itself, 3 times with itself, to get that number, right? Meaning the 27. So you actually have to find a number which is multiplied with itself 3 times to get 27, which is actually 3, right? 3 times 3 times 3. So you can verify that. We verified the answer in step 3. This is another one where we have a square root. If you have a square root, we do what? Power, right? To get rid of a square root. We did power both sides, squaring. Now the left side is 5x because you just cancel a square root and a square, right? The right side you have 7 square, which is 49. And you divided both sides by 5 to get rid of 5x. I'm saying 5 from 5x. And the rest is very simple, right? You just now you got the answer in improper fraction, remember? But you can always convert the improper fraction to a mixed number, right? But check pause when you answer the question. Sometimes the answer might be given in improper fraction, or sometimes it might be given in mixed number. So you just convert it whatever you want. Step 4, we did the verification. We just replace the x by 49 by 5 to see what is our left side and right side. Now we'll also see some equations called inequality. Now inequality we don't have equal sign. We actually have less than, greater than, less than equal, greater than equal, or not equal sign instead of equal sign. What does it tell? Now it actually tells that your left side and right side are not equal, but they are related. They have some sort of relation, because you are saying, let's say, left side is less than right side, or you are saying right side is greater than left side. You see what I'm saying? So you are actually giving some some relation, but not exactly they are equal. Okay. So we also have, equality is extremely important because a lot of times we have to do the same. Okay. Now in equality, we do pretty much the same thing. All the transposing is same. Okay. Like remember, if we have addition, we do the subtraction. You have multiplication, you do the division. We pretty much have the same ideas. The only difference is if you multiply or divide by the negative numbers, we sometimes have to multiply. Remember, at some steps we have to multiply with the negative one, right? Remember in the equal signs. So if we have to do the same here, like multiply or divide by the negative numbers, then your inequality actually flips. That means if there is a less than sign, it becomes a greater than sign. If there is a greater than sign, that becomes less than sign. And that happens only when you multiply or divide by negative number. Okay, that's the only difference. Everything else pretty much same. Okay, and also another thing is in the equality, what do you get? We said, okay, we found the solution for x, and we said this, x equals to 5. That means we are exactly saying x must be equal to 5 to solve this equation. But in inequality, you don't tell x equals to 5. You say x less than 5, for example. That means what? Any value of x which is less than 5 will satisfy this equation. So that means instead of just giving one single value, you actually give a range of values. Because can you tell how many numbers we have which are less than 5? Infinite. You have infinite numbers, right? Because you have all the negative numbers. And we have infinite numbers less than 5. So you are actually giving a range that all this value will satisfy the equation, but not exactly one value, right? Infinite values. Okay. Okay. we always do the testing, right? Let's try a couple of examples. Again, all the steps are same except that, you know, multiplication and division or division by negative numbers. Now a plus 13 less than equal 22. How do I solve it? So the idea is still same, right? So what do you do is this. We have steps here. So we have to get rid of this 13, right? We subtract 13 from both sides. And that's it. So what I got? We got a less than equals 9. That means as long as a equals to 9 or less than 9, this equation will be true. So we check a couple of things here for you in the step 2. Look at this. I selected just randomly. I picked 3 values. I'm saying it's random, okay? You don't have to pick these 3, right? You can select another 3. One is 9, one is 0, one is 13 here. Now I plug 13. You see what happens? I plug 9 here, which makes it 22 smaller than or equal to 22, which is right. So that means 9 is a solution, right? I plug 0 here, then I found 13 less than equals to 22, which is still right. But I plug 13 here, now I have 26 smaller than equals to 22, which is not right. Because 26 cannot be less than 22, right? Because 13 is not a solution. Because remember what we said, any value which is 9 or less, 13 is not less than 9, right? So we just tested, right? We tested with 3 different values, and out of 3 values, 2 values were actually equal or less than 9, but one of the values is more than 9. You know, we just tried to see. So inequality actually gives you a range, right? Because if you plug any value less than 9 or equal to 9, this equation will be true. I'm saying this inequality will be true, right? Let's try another example here. Negative 12 equals to negative 3 over 7 times x. Or no, not equals. Negative 12 greater than negative 3 over 7 times x. Now let's try the steps. Okay. Now here is what we are doing here. Now let's say we want to get rid of 7 first. Okay. Look at, do you see 7 here in the denominator? So we multiplied both sides by 7, then we got rid of 7 in the right side. We still have to get rid of negative 3 here, right, which is multiplied with x. So what I did is I divide both sides by negative 3. But remember, if you divide or multiply by negative numbers, what happens? The inequality symbol operator flips, right? Do you see it flipped here? This was greater than here, right? And this becomes lesser than. Why that happens? Because we divided both sides by negative 3, right? This is what I'm saying? Anytime you divide by negative or multiply by negative numbers, your sign will flip. Now this becomes, so now you know the answer, right? So what is the answer? 28 is less than x. That means what? X is greater than 28, right? So that means any value of x which is more than 28 will satisfy this equation. And we tried some, verification steps here. This is the step 4. So I selected 0, which is less than 28. I selected 35, which is more than 28. I'm saying, we just, let's say check with both values. We'll check. So when I plug 0, the equation becomes negative 12 greater than 0, which is not possible, right? Negative number cannot be greater than 0. Why this happened? Because you selected 0. So the inequality said x must be greater than 28, right? 0 is something not greater than 28, and that's why the equation is not true. I'm saying the left side and right side are not properly related because the 0 is not a solution, right? Similarly, when I plug 35, I got, when I plug 35, I got negative 12 greater than 105 over 7. I did my little math here, and I got negative 12 greater than negative 15, and that is right, right? Negative 12 is greater than negative 15, right? Because 35 is a solution, right? Because 35 is more than 28. Anything you plug more than 28 will actually satisfy this equation. So these are my verification steps. So you don't have to do the verification always unless you want to check. Any question here? No? Yes? Okay. So that's all we have here for today for chapter 12. Okay. So we'll stop our presentation here and then we'll go to the homework section to try the homework for chapter 12.